Picture a data science team at a regional bank. They spend 3 weeks building a finance agent in a Jupyter notebook. Friday afternoon, they demo it. It pulls account history, explains credit decisions perfectly, and the executives approve it for a Sprint 2 delivery. Sprint 2 exposes a central paradox. The model remains accurate and the system prompt is sound, yet the agent fails. The collapse happens at the structural engineering level. Security teams often reject the use of personal credentials for IAM roles. Simultaneously, compliance departments require audit logs of every prompt and response formatted to specific data retention standards. DevOps workflows typically require containerization via Docker files and deployment manifests. Furthermore, platform teams demand secure management of environment variables and secrets, which the notebook lacks. On-call engineers will eventually ask for unit tests and a defined fallback behavior for moments when the model returns a low competence score. These challenges define the Agent Development Lifecycle, or ADLC. Google built the Agent CLI framework to mechanize the transition through these 5 barriers, moving the agent from the notebook into a production-ready pipeline. Effective production deployment is a distinct discipline. It requires closing these gaps with pro-code frameworks rather than treating a prototype as final draft. Low-code visual builders like Agent Studio allow product managers to author intent and reach a working demo in hours. This visual workflow reaches its limit when an agent requires a custom tool, such as executing an internal loan origination API that lacks a pre-built connector. Handling financial data requires deterministic behavior, PyTest unit tests to mock tools, and get history for verifiable audits. To meet these requirements, developers use an export mechanism to move their logic out of the Visual Builder and into the open-source Agent Development Kit, or ADK. This produces a Python structure containing the agent class, tool function stubs, and the system prompt constant. For an agent to operate at enterprise scale, its logic must reside in code to serve as the definitive source of truth. AI assistants often generate invalid cloud configurations because a company's specific VPC topology and IAM roles are outside their training distribution. Without local data, an assistant might write a deployment script targeting an unsupported region or an artifact registry URL that does not exist. Google Agent CLI addresses this through an AI-native architecture. It uses bounded context injection. The CLI restricts the generation space to your exact cloud environment, providing valid API surfaces and existing resource names. Running Agent's CLI Scaffold. Enhance injects this schema to grant project file generation. This process generates pre-populated Terraform modules, a production-ready Docker file, and a requirements file pinned to the tested ADK version. Developers maintain ownership of these outputs. Because they are checked into the repository, the team avoids the risks associated with black box deployments. Executing deterministic infrastructure tasks with a probabilistic text model requires bounding the generation space with machine-readable schemas. Testing agents in the ADK playground allows for quick iteration, but because it runs on personal credentials, it may fail to surface production, IAM errors, or concurrency issues. Achieving production readiness requires a formal evaluate phase using an LLM-as-a-judge pipeline. Instead of manual chat sessions, the team runs the agent against a structured JSON dataset of ground truth test cases. Executing Agent CLI eval runs surfaces failures immediately, like the agent incorrectly invoking an API tool against customer data when it should have declined. These results allow for precise adjustments to the system prompt to restrict specific tool calls before the next test run. Running Agent CLI eval compare diffs these evaluation runs, establishing a regression check within the CI/CD pipeline. In enterprise environments, evaluation acts as an automated deployment gate. It shifts quality control from a post-mortem metric to a prerequisite for release, preventing rogue tool execution before it happens. Compliance requirements generally dictate that any agent making financial decisions must maintain a persistent, verifiable audit trail. The command agents, CLI in for a single project, provisions 3 specific resources for this purpose: a least privileged service account, a Google Cloud Storage bucket for content logs, and a Google Cloud Storage bucket for querying those logs. This command provisions the observability infrastructure independently. It does not create the agent's compute runtime. Deploying the server itself requires agent's CLI deploy, which containerizes the code and pushes the image to Cloud Run. operators should account for Cloud Run's default cold starts, which can introduce up to 1 second of latency. For more sensitive applications, Vertex AI Agent Runtime serves as a faster alternative. Production-grade scaling requires decoupling the agent's logic execution from its logging primitives. A deployed agent operating in isolation cannot be discovered by other enterprise services. To participate in the internal catalog, you must register the agent using the publish command. Once published, agents communicate through the agent-to-agent or A2A protocol. This transport stack utilizes HTTP, server-sent events, and JSON RPC 2.0. A2A is an open standard governed by the Linux Foundation. This ensures the protocol remains interoperable across different cloud providers. Consider a corporate travel request that flows through a travel agent, an expense agent, and an approvals agent. The travel agent retrieves the expense agent's agent card to discover its skills and routing data, allowing dynamic discovery without hard-coding endpoints. To prevent spoofing, A2A secures these handshakes using cryptographic JWS signatures to verify authenticity before data flows. Operating this mesh requires planning for specific failure modes, such as tracing fragmentation due to missing W3C headers or cascading failures from a single degraded agent. Scaling an agentic mesh safely requires standardized, cryptographically verified protocols rather than bespoke integration scripts. Over 7 commands, the fragile notebook prototype is rebuilt into a containerized, evaluated, and observable software service. This stack competes in a crowded market alongside established platforms like AWS Bedrock and Azure AI Foundry. Google's primary advantages in this space are its deeply integrated evaluation tooling and its native support for the A2A protocol. However, teams not already using Google Cloud infrastructure will face a significant migration cost to adopt these tools. There is also a version 1 risk. Agent CLI is a new release from a vendor with a history of sunsetting developer tools. To mitigate this, developers should isolate their core logic within the open-source ADK layer to keep it independent of the CLI wrapper. Maintaining ownership of the generated Terraform ensures that the deployment pipeline remains functional, even if the CLI tool is eventually deprecated. Enterprise AI deployment requires rigorous systems, engineering, infrastructure as code, and strict evaluation gates. Success depends on these technical disciplines, rather than prompt engineering alone.